where people are coming from.
Sure, yeah. My name is Mike Wolodarski. I'm based outside of Philadelphia. I actually run a software company, and in my free time, I'm now starting to work, work with my brother on some climate-related projects, climate and with a particular focus on wildfire. So that's why I'm here. One of the things that we're trying to figure out how to do is basically determine which acres of the forest, starting in California, maybe Pacific Northwest as well, which acres have been treated for what, to prevent, I guess, megafires, not to prevent wildfire, but to prevent megafires with either mechanical thinning or prescribed burns. And so that's kind of my main question. I'm trying to figure out, if the LANDFIRE data can be used to make that determination.
You want me to answer that, Megan?
Beginning.
Okay. I'm Inga LaPuma. I'm a technical lead at LANDFIRE. We have really great annual disturbance layers, and with each pixel that is disturbed comes a disturbance type that's assigned to it. And so we gather all kinds of data from national state agencies about what they've gone out and done, in terms of fuel treatments, prescribed fires, thinnings, all of that. But it also includes the wildfires in that annual disturbance. And so if you go to our website, you can click on disturbance and you can download the annual disturbance. Right now we have only up until we have 2016 that includes the fully remote sensing version. We have, I don't know if we released the limited, we didn't release the limited one. So the next release in June will include up to 2020. So, we have this annual basically an annual accounting of anything that we could possibly find or that folks submit to us that has some disturbance on the landscape. So,
do you mind if I have a couple of follow-ups? I don't know how much time.
No, go for it.
Okay. So just to make sure I understand, so the disturbance data is sourced from reports that are submitted into the system from like forest management agencies, things like that?
So we have several different ways that we get disturbance data. One is, yes, through submissions, national perimeters from our national agencies, such as the Forest Service and the BLM. But we also have state level agencies submitting their disturbance information. So these are just perimeters, right? But then we also go through and do remotely sensed change detection with Landsat imagery. And so that is combined with the submissions that folks give to us. And a lot of times we'll see change in the Landsat imagery, but we won't know what happened there. And the perimeters help inform that. So that's where that data comes in handy, is that we know what the disturbance type was when we see the change detection.
Okay, so that's very interesting. And the remote sensing data that you use, like you have good coverage across the entire United States or just certain spots, or how does that work?
Yeah, we typically do it for the entire United States, Alaska, Hawaii, and Puerto Rico, and all the insular areas. So, yeah. And
how, like, I'll make this my last question for now, unless you tell me I can do more later. And the satellite data that you have, is that something that's also publicly available, or it's something that you have to purchase, or how does that work?
Yeah, for the satellite side, it's all Landsat based, which is all publicly available. We do create what we call our disturbance composites, and that helps us deal with data gaps from clouds and other issues, so that we have a clean image to work with to detect change, because if you have even phenological differences, seasonal differences, that'll look like change between two dates. And so you really need to compare similar seasons to find the actual change on the landscape. So there's a lot of things that can mess you up in change detection. And so the base imagery is publicly available, but the composites that we use in our own workflow, those are not. So
that makes sense. Would I be able to, so I don't hijack any more of this time, would I be able to reach out to you directly and maybe have another follow-up conversation?
Absolutely. Yeah.
Okay.
Yeah, that's my job.
Awesome. Thank you very much.
No problem.
Thanks, Mike. The cool thing is, if you're wondering about that, I'm sure there's other people on the phone call that also have those questions. So it's totally fine to ask those away. And that's what we're here for. That's what this hour is for.
Agreed. Thanks, Megan. Yeah, Mike, you're welcome to take as much time as you need. This is open office, and a little bit of the squeaky wheel gets the grease kind of thing. So if you want to have more questions, go ahead. I think we did get a question through direct message or chat or something about the future of LANDFIRE and budget related questions. Some of you may recall that a couple of years ago there were some suggested cuts to the LANDFIRE budget, and it was a little draconian at the time, and we were scared that maybe LANDFIRE wouldn't be able to continue as it has. We were able to resolve that, and through some belt tightening and some shifting of funds around, we were able to keep the program going. But right now, everything looks good. The budget in this year, and I presume in 23, appears to be fully funded to keep operating. We are trying to change our procedures a little bit, which has increased our expenses a little bit, because we're going to do annual production instead of biannual. Leadership seems to be supportive of this. And you may have also heard that there is additional money in the Forest Service budget, the interior budgets, the infrastructure bill for responding to wildfire risks and hazards. And LANDFIRE plays a role in all of those things, kind of at a background level. There's recognition that LANDFIRE is necessary to do these sort of analysis. And so I expect that the budget future looks good. Not fat. We're never going to be a fat program, but I think we feel secure right now. So I feel good about that, and don't feel the pressure that maybe we felt 3 or 4 years ago. Any other team members who remember those lean and scary days when we were doing different analysis based on Halloween futures and things like that? Maybe not.
Yeah, that's certainly, absolutely, Frank. I remember those days, but
yeah,
but it's good every now and then to sort of have to do a retrospective on what you were doing, and is that what you want to continue to do? And sometimes budget discussions sort of force you to do that. Do some reflection on what's important and then how you go forward. So worked out okay, but at the time it was a little bit edgy, as I recall.
Thanks, Frank. Who's next? You guys all came for some reason, so please unmute yourself and turn your camera on and let us hopefully engage with you in any way you're comfortable.
Megan?
Yes.
Yeah, Tim Haddon here. So I would turn my camera on, but the camera's not working right now. I just wanted to say to folks, yeah, that I've been in the background, kind of lurking during these meetings. I'm the LANDFIRE's USGS project manager at AROS, and if anybody has any questions at any time about USGS's role in the project, or specific questions related to AROS and what we contribute to LANDFIRE, fire away. I'll try and help. And we operate at AROS. USGS operates at AROS through essentially we manage a contract, which we refer to as our technical support services contract, the TSSC. And some of the folks that are on this call right now, like Inga and Julia, et cetera, they're some of our excellent contractors that are really in the trenches doing, a lot of the background technical work for LANDFIRE. We feel fortunate to have them. LANDFIRE is kind of a complex mix of organizations and entities. So if you're confused sometimes, feel free to ask questions, because it is complex and there are a number of different players involved, but ultimately it all results in us producing these great data products that I think many of you have come to rely on or just discovering. So feel free to ask questions anytime.
Megan, we got a couple of questions via email before the call. Would it be okay to address a couple of those, get them in the recording, although I do not see the people who asked those questions on the call?
Sure, I will. Which one do you want to do?
Well, I was just going to go from top to bottom.
Okay, yeah, just read the question out loud so people can hear what.
Yeah, there was a question about using LANDFIRE data to illustrate fire return intervals in Vermont for landscape prescribed fire planning. And we have somebody on the team, Randy, who's not on the call, Randy Swati, has already done some work in Vermont to actually create graphics that you're describing, or that were described by the individual that asked this question. But remember that our fire return intervals that we provide, the fire regimes, are pre-European colonization, not current fire return intervals. So we always have to make sure that people understand that. So that data does exist in LANDFIRE, and we've already done some work, so we could put Randy's email address in the chat or something, and that way people would know how to find that work that's already been done by Randy. The second question was about seeing how data is integrated, how LANDFIRE is integrated with other data sources. And we have it's getting a little dated now, but we have a product that's a website, which we call the WHAM, the Web Hosted Applications Map. And we can put the URL in the chat, that actually displays, 50 plus applications of LANDFIRE data and how it's been used by others and integrated with other data sets that are actually links there. And you can see where that work happened by going to that particular website. So anybody that's interested should certainly go to that website and see some of the different types of applications. And that's certainly that information is probably, 5 years old, 4 or 5 years old. We haven't really updated it lately. So we certainly need to do that or find an alternative. But it's basically, we would say, from bees to buffalo, it's been used in many, many different ways. And we are actually now seeing more integration of different data sets, such as within the Nature Conservancy, combining LANDFIRE data with some of our internal data sets, resilient connected networks and things like that. So anybody that's interested in that, you can contact us directly and we'll provide you with a lot of specific examples of how the data set has been used, both the models as well as the spatial data sets. So literally hundreds of different ways, I would suggest, the ways that we know about, not even including the things that we don't know about, which probably more of those.
And I'll interject, Jim.
Sorry, yes.
I'll just interject that applications will be a real focus for us in our outreach in 2022. So that's something that we are taking really seriously on our team. So keep coming to these office hours if you're interested in that sort of thing.
Okay. And finally, the third question that was sent to us was about vegetative cover in the West. And the LANDFIRE data sets do provide an estimate of vegetative cover for the primary life form on each pixel in 1% classes. Of course, the latest version that you have available will be 2019, including disturbances through 2019. So that information does exist right now in terms of vegetative cover, basically across every pixel in continental U.S., Alaska, Hawaii, and as well as the insular areas. I'm not sure if there was a specific issue about the cover that we provided. They weren't very clear on what the question was. But the second part of the question was about species, and our existing vegetation type that we provide is not a species. It's an ecological system, which is intended to be a vegetative system, not a cover type and not a species. So we don't really map species within LANDFIRE. In some cases, an ecological system is a single species because it's a homogeneous type of vegetation system, but most of them are not. So we do not map species, we map ecological systems, but those systems are described in documents that tell you what kind of species you would expect to find in that ecological system. But we do not provide a map of species. We do have an attribute in our existing vegetation type layer that is the SAF SRM cover type, which is the Society of American Foresters, Society of Range Management. Their standard system is called SAF SRM, and we do have a crosswalk attribute for that cover type within our existing vegetation type layer. But that is crosswalked. We map ecological systems. We map NVC, National Vegetation Classification Group, but we crosswalk to SAF SRM. So if you need cover type, we can give you a rough product that includes a crosswalk cover type. So those were the three questions that were provided beforehand, Megan. If anybody has any follow-ups on those, I'll be glad to try to answer them.
I would just say, Jim, to follow up, that we do have species information from our LANDFIRE reference database that we use to train our models to get the ecological systems. And so if that point data set might help out, that does have species in it.
So yeah, Inga was referring to what we call the LFRDB, the LANDFIRE Reference Database. And there are geo-referenced, highly detailed plots, basically hundreds of thousands of them, that you can download, that are available for download on landfire.gov. And that would include basically the full suite of information on plots, stems, height, cover, species, etc. Really detailed geo-referenced plots. Now there are many plots we cannot provide because they're considered proprietary, such as FIA, NRCS plots, and things like that. But we provide every plot to the public that those who supply them to us allow it to happen. So but there are hundreds of thousands, and it's definitely an underused asset. And if you need geo-referenced data points with vegetation, that's a great place to go start.
Keiko had a raised your hand, so feel free to chime in. Thanks, Jim.
Hi, thank you. My name is Keiko. I work for a company called Climate Engine, and we are very much interested in more like application of LANDFIRE data. But my question here today is maybe not directly related to the data set from LANDFIRE, but I'd like to take this opportunity to ask fire specialists in general about how to use the LANDFIRE data, especially when it relates to burn probability. I noticed there are a lot of burn probability mapping done using the data from LANDFIRE. So when I initially take a look at burn probability, I mean, as the name suggests, it should, I thought, the likelihood of fire. But when I overlay with actual burned areas, it doesn't really overlap very well. And I'm learning by reading a lot of paper that actually burn probability is not an appropriate layer to validate with actual fires. So I'm a little bit, maybe I need some clarity or advice from others. How can we use data from LANDFIRE, especially fuel load related, in relation to understanding about fire from the fuel load perspective and the likelihood?
Well, I'm hoping somebody else will take this. I'm not a fire
I was like,
person.
is Frank going to say it? Or okay, so Frank, you can probably back me up on this. But
Yeah.
so
You
a
go
lot
first, Inga.
okay, so the LANDFIRE data is you're right, it's typically used in a lot of these hazard models, right? And so part of that is calculating burn probability, and we kind of package our data in what's called landscape files, and that includes the fuel layers, the veg layers, as well as the canopy layers and the topography layers. And so models such as FlamMap, Farsight, FSIM, they take these landscape files in and they essentially look at fire behavior and rate of spread, flame length, things like that. And that's part of, just figuring out what is the probability that an area will burn with these fuels, right? So, so part of our LANDFIRE's responsibility is to try to keep those fuel layers and all the other ones as up to date as possible. And so that's why we try to incorporate those annual disturbance layers to understand how that's going to change the fuels, and try to provide the most recent fuel information for these models. And so essentially we're trying to get the fires that already burn on the landscape, that's going to reduce the fuel there, right? And so when you run a fire behavior model through, then hopefully, that it will be reflected in the burn probability. Does that answer your question at all? I mean, I'm not sure if that's where you were going, but that's kind of how I interpreted it.
And Keiko, I'll follow up and say that different organizations with different goals and constraints calculate probability differently. There is no one way to do that. Mm-hmm. There's a map called the Wildfire Hazard Potential Map that was created by the Forest Service, but it's specifically supposed to be calculating the probability of a wildfire that is difficult to suppress. Not any wildfire. Mm-hmm. In the South, they incorporate things like where are the fire stations themselves in terms of difficulty of actually suppressing the fire or responding to the fire. So it can be fairly simple or it can be really complicated. So there is no one way to approach it. Just think of the data sets that we provide basically as the supporting information that's used to create a probability of a fire, and then perhaps even what the intensity or the severity of that fire is going to be, under what weather conditions. So it's really just background information that's used in many different ways to look at fire and how fire is on the landscape.
Kim's right. I'll give an example of the one I'm probably more familiar with, is the Large Fire Simulator, or FSIM. It was developed at the Zula Fire Lab, part of the Rocky Mountain Research Station. And what it does, the primary components are the fuels, the topography, and the fire weather, and historic fire incidents. And it combines these in an analysis that predicts where a fire might start and where it would burn over the course of a fire season. And it goes back to the historic weather conditions and picks a weather from that happened on that day in a historic year and use that as a simulator. The ignitions are somewhat random, but not entirely random, because it does look at where actual fires happened. So it projects this across for a hypothetical fire year. Then it does it again, and then again. They end up doing 20,000 hypothetical fire years in a Monte Carlo simulation. And then they record how many times each pixel was burned over those 20,000, 30,000 runs. There's different numbers of runs depending on how complicated the landscape is. And then that's how they come up with the probability. So it may say that a probability is that this particular area will burn once every 150 years. That doesn't mean that every 150 years it's going to burn. It may burn every year for 5 years in a row, or it may not burn for 500 years. So it's a useful metric, but it's not very good at predicting where a fire is going to happen this year or next year. So those are more complicated. And in the Forest Service, we lean more on an outfit called the Predictive Services that works over in the National Incident, NIFC, National Fire Incident Center in Boise. And they do a 3-month prediction about where they think the fire activity is going to be highest over the next 3 months. And they update that each month for the next 3 months.
And a couple of things they go to add to that, which is LANDFIRE does produce what they call MoD-FIS, which are modulated fuel models based on the sort of recent weather conditions. So they'll produce these seasonal fuel models, which give you a little bit, a better idea about how fuels might react this year based on what's happened this year climatically, or since the last disturbances have been included. Okay, so those are called MoD-FIS, and you'll find those on landfire.gov. So they do try to do that, but it is very complicated to talk about where will fires be this year. And you might also look into something from a Forest Service researcher named Matt Reeves, who creates something called FuelCast, which is mainly, I would say, for the West, right, Frank and Inga, it's shrubs and grass and how they change during the year and how their response to fire might change during the year. So it's R-E-E-V-E-S, Matt Reeves, and he calls his system FuelCast.
MoD-FIS is an acronym only a bureaucracy could come up with. It stands for Modeling Dynamic Fuels with an Index System, but MoD-FIS.
And basically it's comparing the 10-year kind of maximum greenness level, so your NDVI, to the current years, and it's adjusting our fuel models based on that difference.
Great, this is very helpful. Thank you very much.
Thanks for the question, Keiko. If you'd like to reach out to Inga or Frank or Jim, let me know and I'll provide their email addresses to you. It's no problem. Who's next? Go for it, Mike.
Okay, thanks. I wanted to ask just kind of a general question about the frequency of the data that LANDFIRE provides, maybe, putting focus on the disturbance data that Inga mentioned. It sounded like the data might be available on an annual basis, so like with a 1-year delay. But then I also saw some things about like the 2016 remap, which maybe suggested the data has maybe a longer delay than a year. So just kind of wanted to ask about the frequency and the delay.
Yeah, sure. So, so the goal is to have disturbance from basically the season before represented in our release, but we're not there yet. So basically right now we have up to 2016 annual disturbance with that remote sensing aspect. And then in June of this year, we're going to have up to 2020. And then the hope for the upcoming years is that, so we'll release 4 years this June, then we'll hopefully have 2 years, 2021 and 22 for the June after. And then hopefully we'll get to just having the disturbance from the year before. So that's the goal. There's a lot involved with that. You know, we actually have image analysts looking at all the tiles across the United States to kind of make sure that what we're detecting as disturbance is an actual disturbance. And so that takes time. So, but we do have a lot of confidence in those disturbance layers because someone actually is looking at every disturbance and saying, yes, this is real. Yes, this is not. So.
And I'm going to add something, Mike, with hopefully not confusing you too badly, because trying to explain this is very confusing. The 2019 L product does include disturbances up through 2019 that were sent to us by the different federal programs or mined from reports, etc. No remote sensing. However, you'll find in the fuels layers and the veg layers, they've actually projected it forward to the year delivered. And they call that capable fuels and capable veg. It just doesn't include disturbances that happened between 2019 and the year it was delivered. So the veg and fuels has been projected forward in terms of what we think it would be right now based on disturbances through 2019. Does that make sense to you, Mike? That's a hard thing to explain.
So if I wanted to get a sense of the current canopy, I could use the 2019 data from the 2019 release, but that would be potentially inaccurate because it's not backed by remote sensing data. It's extrapolated from a previous year with the submissions factored in.
I wouldn't call it inaccurate. I would call it incomplete, because we did not go find disturbances that were unknown to us. In other words, we didn't go looking for disturbances, but it's not less accurate. It's just incomplete. Okay. And understand that projection forward is only for areas that were disturbed within the last 10 years. Okay. We assume that things don't grow that much in a 2 or 3 year period. In the future, that's going to change. But right now, we're just sort of not projecting forward areas that were not disturbed. But we will be doing that in the future. So don't think of it as less accurate, just less complete.
Okay, that makes sense. And just a really quick follow-up to that, what would be the best way to be able to see, like maybe using Landsat, where actual fires have taken place, since obviously there's been some mega fires in 19 and you know, in 20 and 21 that probably changed the landscape quite a bit. What's the most up-to-date way to do that?
I'll pass that to Inga. She's the expert, so I'm going to send that one to her.
Of course, my dog's barking now, but I think Diana put in probably the best source, which is the NIFC data set. Diana, are you still on? No, I don't see. Okay. Yeah, yeah, it would be the NIFC. I think that's on ArcGIS Online, the public version. So they have the most recent perimeters up through, I saw 2021 on there today. So that's just perimeter data though.
Put that link in the chat window, Inga. Thanks. Kate, did you have a question or a comment?
Yeah, I did. Sorry, Megan, I was a little slow on the draw there. Back to Keiko's question and also what Jim had mentioned, some of the things that now me stepping back out of the national role as a practitioner again, the thing to keep in mind that one, it's a model, things are modeled. We talked about extrapolating, but yes, also the other big point is that agencies/bureaus do use risk stuff differently. Jim mentioned we don't expect things to grow back quite as fast in 2-3 years. Completely different for me in the Fish and Wildlife Service role as far as some of the ecosystems we work in. So just thought I'd be remiss as a practitioner if I didn't mention that.
Kate, can you tell us where you're tuning in from and what you do, just for the whole group? Sorry, I'm sure most people know, but.
Yeah, no, hopefully most people don't know me. I'm the fuels fire planner for the Region 6 of the Fish and Wildlife Service, and I'm actually stationed in Brookings, South Dakota.
Thanks for that. Who would like to go next?
Can I follow up on that? We're trying to get to the point where we can use current imagery every year to update our layers, and so that will take at least some of that that modeling out. Right? We're still modeling across the landscape based on our input layers, but the imagery will be more current, and so that hopefully will help us kind of move into that next generation of LANDFIRE.
Yeah, and Inga, I mean, there's obviously no fault. There's no fault of your own, and I appreciate it. Trying to get.
I wasn't even here. No, I'm just kidding.
I appreciate that, and always trying to get real time is the best. I guess my comment was more towards the risk modeling.
Mm-hmm.
Being familiar with that last Forest Service risk effort that Jim had mentioned, that it's a sticky wicket, and I just wanted to make sure I brought that up.
Yeah. Good point. Yeah.
And Tate points out something important too, is a real challenge for LANDFIRE is trying to be consistent across geography. Like, because we have to model Puerto Rico and Alaska, and Samoa and Maine, so it can be quite difficult, not just mentioned time-wise, but just to have a consistent product across that kind of geography. Geographical variation is really difficult, but it is in effect in the charge for LANDFIRE to be as consistent as possible across space so that conditions can be compared across space. And obviously some of our models and assumptions work better in some places than they do in others. And we're just hoping to get to a point where they work a lot more consistently. And I think that is why one of the reasons we need to go to annual, because where I live in Florida, 2 years growth in fuel is a lot, okay? But it's not much in some parts of the country. So it is something that we're trying to work on and recognize that it is an issue to try to be as consistent as possible across geography and across time as well, so that we can compare across the temporal scope as well. So those are both challenges that we're dealing with right now.
Thanks, everyone.
I agreed with Jim. I should have introduced myself when I talked earlier. I'm Frank Fay. I'm the Forest Service Business Lead for the LANDFIRE program. I work in Washington, D.C., and I've been with LANDFIRE since 2009. My counterpart, Henry Bastian, is taking some time off today. He's with the Department of Interior. He's been with LANDFIRE since 2004, something like that. Jim's right about comparison, how they're important. My dad used to always say comparisons are odious, which I thought meant they stink, but it turns out odious doesn't mean they stink. But one of the problems with temporal comparisons is that we change our procedures over time. And the way to not have that would be to keep our procedures the same every time. But that would be turning our back on the latest science and the latest technological developments. And so LANDFIRE has tried to put themselves and walk that fine line. And when there's a new technology like LiDAR, we debate whether it's important enough to incorporate that or not, so that we have more consistency with the previous version. In the case of LANDFIRE, we did incorporate that. And now we have much better estimates of height and cover. So it's a little dangerous to compare one version with the previous version, but there's a table that I think there's been a link provided. And he tells some of the caveats and some of the watch outs if you're doing those comparisons.
Who's next?
I'll jump in if.
Go for it, Michael. Yeah.
Hi, so my name is Mike Odell. I am working at a very small startup, and we're looking at trying to help people structure their immediate landscape in their homes in such a way so that they can survive wildfire. It's a big problem in California. I'm in Alameda, California. So I've spent the last several months building a model that looks at the fuels around a home, and we actually build an internal representation of the landscape. We use aerial imagery. We recognize trees through machine learning. We identify the footprint, identify other structures around it. And then we have pretty much a deterministic physics model, some probabilities, but mostly deterministic. And we decide, and we figure out where the structure is going to fail, given the different fuels. And then based on that, we come up with mitigation plans. So one of the things that I've been looking at, so the kind of not even a .1 version of it, but we've got something functioning. The next layer is to try to better understand the fuels that we're seeing. So for us, we're right now, we're not so much worried about surface fuels. We're more concerned with the trees, but we have no idea what trees we're looking at. So I'm looking for some ground truth data so that I can start training some deep learning models to recognize different tree species. And I'm, happy to use and have available multispectral imagery from fixed wing and from satellite. But I just need ground truth. I just need to know, here's a patch of trees, a whole bunch of patch of trees, and this particular tree is this species, that particular tree is that species, so that I can start labeling. I don't know if anybody's used your data sets for that, if that's an appropriate use of your data sets. I'm literally just kind of casting about trying to find, some data that I can use.
I'm going to jump in, Michael, just so that we actually kind of addressed your question earlier. I see now that you submitted that question.
Sorry, I was at the dentist trying to get done with it.
But that's okay. But I will say again that we don't map species in LANDFIRE. But as Inga pointed out, we do have a georeference plot database that you can download that has species information in it. And perhaps that would be useful to you. And I'm sure that Inga knows there's lots of work going on in California, Mohammed, somebody at UCLA, and other people. So Inga might have some other ideas for you as well, Mike.
Okay, great.
Yeah, we definitely have seen folks attempting to do similar things. And our LANDFIRE Reference geodatabase is what we use to train our models. And so it does have plot locations and species and cover and lots of information for each plot. And that's available by geo area. So you would have probably in California, the Southwest geo area would be what you would want to look at. But like Jim was saying earlier, there's a lot of plots in there, like the forest inventory analysis plots that we can't release. And so they're just, with data agreements and things like that. And so it's the public version of what we use in-house. I know that Mohammed has been attempting to use it for deep learning models to identify surface fuels and canopy fuels, but it's one of the issues is that it's not a balanced data set. It's whatever we get from people. And so you'll get like lines along roads, and you'll get a ton of plots in the sequoias or something, so it's not balanced by any means. And so that's an issue that I think anyone trying to use that data set for training is going to have to deal with. So
thank you.
Michael, I can forward you Mohammed's name at UC Davis. Probably shouldn't give out his email, but you can find it. You can find his email if I give you his name.
I may have come across him earlier in my research, but yes, if you could forward that, that would be helpful.
Sure thing.
I guess I should add that, some of our, exploratory innovation things that we would like to do are, using both LiDAR and imagery to try to do similar things, right? So get at the species, also thinking about using hyperspectral data as training with some of the hyperspectral signals that you can pull out actual species. And then also the phenology, the time series of how different species give off their signals and green up and senescence and things like that. So all of those things would help, right?
Yeah. No, there's some interesting research out there. I've forgotten who it is. There's someone out of Purdue that's been using a lot of hyperspectral imagery, looking at recognizing tree species. So.
Thanks for the question, Michael.
Thank you.
I'm going to put up a quick poll, an evaluation poll to help us make sure that we are checking in with our audience. But we still have a few minutes left if anybody has any final questions before we end our last office hour of 2021 or any follow-ups.
I would just throw something out just from my perspective and introduce myself. I'm Jim Smith. I'm the program lead for LANDFIRE within the Nature Conservancy. And I have to throw out sort of a something about conservation. We've been talking a lot about fire here, but we support a lot of non-fire applications as well, and hope that you will take a look at some of the products that the web-hosted application map, look at Conservation Gateway, explore landfire.gov. We have a YouTube site. We have a Twitter account, all these things, because there's so many different ways. The world is data poor, believe it or not. Despite all these satellites and all these kinds of ways we have to get data now, we're still information poor. And we hope to provide information that serves a lot of different communities. Fire would be our primary community, but not our only community. So definitely, if you're not involved in fire, don't think you're left out of this. You're not. If you have any questions at all about any kind of application about LANDFIRE products or any of our state and transition simulation models or any of our tools, don't hesitate to call us, but definitely explore our resources if you have any interest in really looking at continental scale data sets. There aren't that many out there, certainly not that many with this depth and richness to them. So we look forward to working with you in the future if you have any needs.